Hello everyone, this is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering College, Department of Electrical and Electronics. Today I'm presenting about armature reaction and commutation process for DC motors. It is related subject about DC machines and transformers. Now let us go into the topic. Armature reaction and commutation for DC motors. This presentation will delve into a fascinating world of DC motors focusing on two crucial components. Armature reaction and commutation will be explore the principles behind these phenomena, analyze their impact on motor performance, and discuss methods for ensuring efficient operations. So these are also different types of armature reactions and commutation process of DC motors. In further slides, let us know what is armature reaction and the commutation process in the DC motor. First of all, let us know about armature reaction. What is armature reaction? Armature reaction, it is armature reaction is a effect of armature flux on the main field flux in a DC motor. And introduction to DC motors are direct current DC motors. DC motors means direct current. It has no sine wave. So DC motors are electromechanical device that convert electrical energy into mechanical energy. They rely on the interaction between magnetic field and electric current to generate torque, resulting in rotation. Their key components are DC motors typically consist of a stator, rotor and commutator and brushes. The commutator collects the current and the commutator rotation. AC current is induced in the commutator, so the it converts to DC. While armature rotating AC is induced, the commutator collects the current and it converts to DC current. And brushes, the starter houses of the stationary magnetic field, while the rotor carrying the armature winding rotates within the field. The commutator and brushes fabricate the following current to the armature winding, ensuring continuous rotation. These are the continuous rotation. These are about the introduction to DC motors. Now in the further slide, we may know about what are the types of armature reaction in the DC motors. First of all, the armature reaction in the DC motor is armature reaction means the armature flux, the effect of armature flux on the main field flux of a starter or rotor or field winding is called an armature reaction. Magnetic field distortion. First one is in armature reaction. There is a magnetic field distortion where GNA and MNA axis, geometrical neutral axis and mechanical neutral magnetic neutral axis are both are equal and perpendicular. When the commutator rotates, the magnetic neutral axis is perpendicular to the resultant flux and the current flow and the torque production. Now the torque production, sorry for video. Torque production, the armature winding carrying current generates its own magnetic field. This field interacts with the main magnetic field and causing distortions. The distortion can be reduced and strength uniformly of the magnetic field, affecting torque production. And now to factors affecting armature reaction. Here there are many factors affecting the armature reaction. Now let us what is the main factor that affect the armature reaction. Now let us know. Armature current. Higher armature current leads to a stronger armature field, resulting in generate distortion. And the second one is magnetic field strength. The weaker main magnetic field is more susceptible to distort by the armature field. And these are the main armature magnetic flux due to the armature reaction susceptibility for the distortion of an armature field. And the armature winding configuration, the armature winding configuration, this type of arrangement of armature winding can influence the magnetic and the pattern in the magnetic field. So these are the different types of factors that are affecting armature current, magnetic field strength and armature winding. The in armature current, there is a higher armature current leads to stronger armature field. More the current, more the stronger armature field resultant generate the distortion. Anything that can be done in more efficient, it may lose or it may affect. The magnetic field strength, as the weaker main field flux is more susceptible to distortion by armature field than the armature winding configuration. The type of arrangement, the armature winding and number of turns may affect the magnetic field and the coil's strength of the armature field. It may or may not be equal, but it is similar to the field winding that is done by the armature main field flux. So now coming commutation in DC motors. First, commutation current reversal. While armature rotation, the AC current is induced in the armature, and the commutator. What the commutation processes do? The commutator collects the AC current and converts into DC current, direct current. AC means alternating current. It collects the alternating current which is developed in the armature, and the commutator it what we call it changes the AC current to DC. AC alternating current to direct current, and the commutator and the brushes collect the current. Continuous rotation. Continuous is the commutation is the process of reversal the current direction, and in the armature winding the appropriate intervals. This ensures that the armature continues to rotate in the desired direction despite the alternating current flow. This is achieved by using a commutator and brushes which effectively switch the current path within the armature. Yes, what we said is right. The armature, while rotation of the armature, the flux is developed and AC current is induced at the armature, and the brushes collect the current, and the commutator process is to do that. The alternating current, it shifts the alternating current, and it gives the DC current, DC output in motors. In AC motors, there is no commutator. And now let us discuss about furtherly commutator and brushes construction. How the commutator and brush construction is given. The commutator and the brush construction is followingly. Commutator, it is segmented cylindrical structure made of copper bars. It is connected to the armature winding, allowing current to flow the different segments based on the rotor position. Brushes are typically made of carbon, providing electrically contact within the commutator segments. They wear down over time and need to replace them. In brushes, the brushes will wear and tear if there is no proper process, and in the overtime it may be damaged or damaged for the. It is a main source where the voltage cannot be developed. If over time the brushes should be changed for working a motor properly or functioning the motor proper. And importance of proper commutation. uh, there are two types of commutations: poly AMG rotation and the Qualfeld soft. Mainly the importance of proper commutation is smooth operation, extended lifespan, reduced energy consumption. Smooth operation is nothing but if any device that can be handled softly, it may extend the lifespan of that device. Smooth operation, proper commutation ensures smoothly and efficiently motor operation without excessive sparking and vibrations. Extended lifespan. Good commutation minimizes wear and tear on the commutator brushes and other motor components, extending this lifespan of the motor. Yes, it is true. Reducing energy consumption. Efficient commutation reduces the energy losses associated with sparking and other inefficiencies, result the lower energy consumption. So these are the important of proper commutation process. And the next one is troubleshooting commutation issues. Expensive sparking, uneven rotation, high motor temperature. These are the troubleshooting commutation issues. Let us briefly know about everything. Excessive sparking. Check the brush wear and alignment, commutator surface condition, and motor speed. Excessive sparking indicates the problem of commutation and potentially due to a worn, misaligned brush and damaged commutator, incorrect motor speed. Even rotation, check the winding, commutator and the segment condition, and the brush cannot be pressured. Uneven rotation can be caused by issue with the armature winding, commutator segment, or brush contact. And conclusion and the key takeaways are: Armature reaction and commutation are fundamental concepts of DC motor and explain the operation. Understanding these phenomena crucially for optimizing the motor performance, extending lifespan, troubleshooting the common issues by addressing factors affecting armature reaction, and ensuring the proper commutation. We can achieve smoother operation, reduced energy consumption, and enhanced over motor efficiency. So these are the conclusion and the key takeaways of DC motor and DC motor commutation process and brush contacts. So in this way we can extend the lifespan of a DC motor by generally arranged and smoothly processed of the DC motor. In future enhancement, it can be increased with different types of functions and different upgraded versions. So these are the conclusion and key takeaways. Furtherly, we may discuss or not at the future upgraded versions. At present, we have these types of key takeaways. Thank you. Thank you.